Hi, welcome to my video on adding and subtracting cubic radicals. To add and subtract any radical, they have to have the same root and the same radicand. And what I mean by the same root, right here, this number, this is the square root, it has to be a 2, and the radicand is what's on the inside. So this is the radicand in here, and this is the root right here. So this is the square root of 2, and that's the square root of 3. And we have the cube root of 5 and the cube root of 7. In order to add, they would have to have the square root and they have to have 2's. So 2 cube root, 2 square root 2, they're the same because they got the same, they're square roots and the same radicand. In order to add or subtract here, I have to have a 4 root 3. They have to have the same root and the same radicand. And you can't add these, they're the same roots, cube roots, but they're not the same radicands. So let's explain further, more work. Examples, like cubic radicals. Notice that this is a cube root, cube root, cube root, cube root, and they're all 2's on the inside. So they're all like radicals. The only different is that this is a 1 times, that's a 4 times, that's 1/3 times, and that's -5 times. But they're all like radicals in that they're all cube roots and they all have the same radicand. Now, these are examples of unlike cube root radicals. They're all cube roots, cube root of 3, cube root, cube root, cube root, cube root. But the radicands are 4 and 7 and 10, 6 and 11. So no matter if you put pluses or minuses between these, you can't add them because they got to have the same root and the same radicand. In other words, the same number or expression underneath the root and the same root. Now we have unlike radicals. That's a square root and that's a cube root. You can't add these, even though the radicands are the same, but the roots are different. That's the square root of 6 and that's the 4th root. You can't add any of these because that's 4th roots. And there's no more 4th roots here. There's radicand of 2 and 2, but that's a 4th root and that's a 6th root. That's a 6 and that's 6, the same radicands, but that's the 5th root and that's the square root. Again, square root understood to be a 2 there. Square root understood to be a 2 there, even though we don't put it in. Okay, hopefully that explains about adding and subtracting. When we're going to add and subtract, we have to have like radicals. Same index, square root, and the same radicand. Which radicals are like the cube root of 5? So, cube root of 5, cube root of 2, nope. 5th root of 3, nope. This is the cube root of 5, yes. It's 2 times, no. -8 times the cube root of 5, yes. Cube root of 5, cube root of 5, and that's the cube root of 5. They're the same. Which radicals are like the 4th root of 6? You got to have a 4th root, you got to have a 6. No, reversed. 4th root 6, yes. 5th root 6, no. 4th root of 6, but it's negative, yes. Cube root of 6, no. So these two, right here, are like this one. So, if you know which ones are like, you can only add like radicals. Same index, square root, cube root, cube root, 5th root, and the same number or expressions underneath. So we're going to add cube root of 2, they're like radicals. So 4 plus 5 is 9, cube root of 2. We're going to add here, and we can't. We can't add these. They're cube roots, but they're not the same radicand, so it stays like that. Cube root of 6 to cube root of 6, they're the same. So negative 9 plus 2 is a negative 7 cube root of 6. Cube root of 3, cube root of 4, cube root of 3. So these two can go together. That's a 1 and a negative 6. So that's a negative 5 cube root of 3 plus the cube root of 4. You cannot add the cube root of 4 to the cube root of 3. You can only combine these two, which gives me this one. E, I'm looking for like radicals. Cube root of 4, cube root of 4, so these two go together. 7 minus 5 is 2. And cube root of 7, cube root of 7, they can go together. That's a 1, that's a 10, add is 11. Cube root 7. And you can't add these because they're not like radicands. Same roots, but not the same numbers underneath. Same radicands. Okay, more practice. Don't forget, you can pause the video and work these out and see if you get them right. Good practice. We're going to add and subtract. Cube root 3, cube root 3, perfect. They're all the same. So they're all cube root 3. 4 add on 1 is 5 minus 2, 3, cube root 3. Are these the same radicals? Radicand? Yep. That's a 10, that's a 10, that's a cube root, they're the same. So 11 minus 15 is negative 4. Cube root 10. Number 3, we have 4 terms. For, let's see, cube root of 2. Nope. Right here, yes. Cube root of 2, cube root of 2. Negative 6 subtract 1 is a negative 7 cube root of 2. Cube root of 9, cube root of 9, so we can add these. Negative 7 plus 4 is negative 3 cube root 9. And just a reminder, you're adding these, so that's just like saying 6x add on 2y plus 3x plus 4y. When you add these, you can only add like terms. So that's a 9x, because these two are alike, and these two are alike, 6y. So what we're doing here with these variables is the same as we're doing with the square roots. We can only add the ones that are alike. And we have to add these, but we do not alike, but we got to check. We got to make sure the number is simplified. 16 is 8 times 2. And 54, perfect squares, 27 times 2. So the cube root of 8 is 2. That's cube root 2. Cube root of 27 is 3. Cube root 2. Now that I have them simplified, I can add. These are like radicals. So 2 plus 3 is 5 cube root 2. So always simplify the inside. And we do the same in the square roots. We always simplify inside the root, if possible. And so this is 4/5, and that's the cube root of 3,000 is 1,000 times 3. And 325 looks like it's a 125 times 3. You could prime factorization break it down. You can. But once I recognize 1,000 here as a cube root, so there's a cube root left off there. That's it left off there. So the cube root of 1,000 is 10. Cube root 3. 3/5. Cube root of 125 is 5. Cube root 3. Let's multiply PEMDAS. We got to multiply now. 5 into 10 goes 2. So that's 8 cube root 3. 5's cancel. I get a negative 3 cube root 3. these two radicals are just like, so 8 subtract 3 is 5. So it's 5 cube root 3. So you always simplify if you can. 2/3, 7 is only one of them, so we can't simplify. 1/6, and we want to make this a little bit shorter. 56 is their perfect cube here. Let's see, 7/8. I see 56. I see a 2. 2 into that is 28. 2 into 28 is 14. 2 into 14 is 7. So that's a 2 times 2 times 2 times 7. So that's a cube root. So we got 3 of them. So that becomes 2. That's an 8. 2 cube root 7. A hint, that's a 7. So if this is going to simplify, I have to have a 7 inside of here. So that's 2/3 cube root 7. And 2 into 6 goes 3, so that's 1/3 cube root 7. Remember, that's 2 over 1, so they cancel. That's 2 over 6, which is 1/3. 2/3 and 1/3 is, common denominator is 3, so we add. 2 plus 1 is 3, so that's 1. 3 over 3 is 1. 2/3 plus 1/3 is 1. So it's the cube root of 7. Simplifies to. And we have fractions. Cube root of 2. Cube root of 2. Now these can all go together, but I need, because I don't have to worry about the radical, I only got that add and subtract the fraction. The common denominator, 8, 4, and 2 is 8. Put down an 8. So that's okay. That one is, I need an 8. So 4 into 8 goes 2. 2 times 1 is 2. 8. 2 into 8 goes 4. Cube root 2. So I have the cube root of 2 for all of them. I got an 8 common denominator, write it down. So -3 plus 2 is -1. Minus 4 is -5. So it could be -5 over 8 cube root of 2. And again, you could add on the negative here. That's a add on -4. So -3, 2. But that's a subtract. And that brings us to the end of simplifying the radicals, simplifying, adding and subtracting radicals. Simplification, doing adding and subtracting. And adding and subtracting, you need like radicals, the same root and the same radicand. If you like my video, click the like button, click the subscribe button, click the notification bell, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel, Math Fully Explained. Thank you for viewing my video. Bye-bye.